Good afternoon, students. In today's lecture, we will study about a very good programming IDE. It has a language of its own, and it also has several simulation toolboxes, and this is called MATLAB. MATLAB is a very popular, very largely used software for programming, especially scientific computation, all over the world. And because of its popularity, there is huge amount of community support for it. So this is why it is very popular, because it has a very simple language which is easy to learn. It has steep learning curve, and it has so many predefined useful functions that it becomes very easy for code development in MATLAB. This is why MATLAB has become very popular, and as far as engineering and scientific computation is concerned, MATLAB is used in almost every university and industry of the world. So it is always a good idea to have good command on MATLAB software. In this lecture, we'll just take a brief introduction of what are the special features of MATLAB and why it is so useful. MATLAB is just like any other programming language. For example, we know about C, we know about Fortran, we know about Python. Python is very popular nowadays because it is very largely used in AI model development. C is very useful in embedded system development because it runs very close to the hardware. This is why, as far as embedded systems are concerned, C is very popular. Fortran used to be the most favorite language of scientific computation of yesteryears because Fortran is a very fast executing language. Even today, if you compare Fortran with any other modern language of today's times, Fortran is still the fastest executing language. But because very few people are there who are available to understand, who understand Fortran fully well, and also because of the advent of other more user-friendly languages, Fortran has become less popular. So nowadays, Python and MATLAB are very popular. Python has an advantage that it is free. MATLAB is commercial software package. You have to pay for it. But most universities in the world and most industries have their license. So user may not find it difficult to code in MATLAB. So if you look at the basic features and advantages that we have in MATLAB, it is a high level programming language, and because of its ease of development, it is very easy to learn and develop code in it. It has very good toolboxes for visualization, graph plotting, publication quality graphs. Everything can be very beautifully created using MATLAB. This is why in research community MATLAB is very popular. Most of the graphs that we see in research publications, they have been created by MATLAB or similar softwares. Main purposes for which MATLAB are used is basically analyze data, development of algorithms, and create models and applications and softwares that do some scientific computation. Famous applications, most popular applications for MATLAB are signal processing, communication. Image processing is a very powerful toolbox in MATLAB. Image processing toolbox of MATLAB is very useful and it is used a lot. And then we have other computational sciences, whether it is computational biology, in chemistry, in physics, computational electrodynamics, all other computational arena of scientific community, they make use of MATLAB a lot. Key features of MATLAB are that we have already said that it is a high level language, basically meant for numerical computation. From linear algebra, statistics to Fourier analysis and solving of ordinary differential equations, we have numerous predefined functions which are there available in MATLAB, which makes life very easy. Using other programming languages of past years, for example C, if you want to solve a differential equation, you have to write the entire algorithm for that purpose. But in MATLAB there are predefined functions. You can directly call the function, and it immediately generates the result. So coding becomes very easy. Solving scientific problems become very easy because a lot of hassle has already been taken care of. So there is a very little for the user to do. this is why people who have a very humble background as far as programming is concerned, they can easily use MATLAB, while it can be very challenging for them to use hardcore programming languages like Python or C. So what MATLAB is actually? MATLAB is basically, as the name says, MATLAB is an abbreviation, a combination for matrix laboratory. Why it is called matrix laboratory? Because in MATLAB, every number or every set of numbers, every data set is seen as a matrix. For example, a scalar value is seen as a 1 into 1 matrix, 1 row, 1 column. A vector is either seen as a column matrix or a row matrix. It is also called column vector or row vector in MATLAB terminology. Tensors are seen as multidimensional matrices. So because it is handling everything as if it is a matrix and perform matrix operations very easily, this is why it is rightly called matrix laboratory or MATLAB in short. So let us be familiar with what we see the moment we start this application. When you start up MATLAB, so this is what comes on your screen. The main part is the editor in which you write your code, the main code. Then the second most important part is the command window. Command window is the region in which the output of execution of each command is echoed. In addition to this, you have a window pane which tells about the current folder you are in, which has all the files available for execution. Then there is a workspace region which tells you which variables have been created, what are their size and what are their data types, what are the values in them. So this region, workspace, is meant for that. A command window has a prompt. This double arrow or double greater than sign indicates prompt. Whatever you write it on this prompt and hit enter, its output will be echoed as it is in the next line. So this is the purpose of command window. You can either write your code on the command window if you have to write just one line, but if you have to execute a huge number of lines, so those huge number of lines are to be first put in the editor. They are edited, checked, and after execution you see whether there is any error being echoed on the command line or not. If there is no error, it yields the desired output. So now let us see how the command window works and how different commands get executed on the command window. The simplest example is assignment. In this example, we assign a value to a variable. A is a variable to which 5 is being assigned. Equal to, just like any other programming language, equal to is the assignment operator. When we write A is equal to 5, that means a space gets created in the memory and its name is A. In that space, 5 is stored. So that means we are assigning the value 5 to A. So we see that A is equal to 5, that means A is a variable to which the value 5 has been assigned. The moment you write A is equal to 5 and hit enter, the output is echoed immediately on the screen. In this command window, you see that it is telling you that A is now equal to 5. Similarly, you can create other variables also. In other variable, we have created another variable B, which has been assigned the value 3, and similarly it is also telling you that this is now equal to 3. Using these variables, several operations can be performed. For example, you can perform mathematical operations, you can perform reshaping operations, or other type of function calling, looping, etc. As a simplest example, I am showing over here that two variables are being multiplied and the result is being assigned to a third variable C. In this line you can see this is a mathematical operation being performed. A multiplied by B generates some value and that value is assigned to C. C is equal to 15, which is rightly the product of A and B, 3 into 5. So in this way you can assign the value directly, or you can assign the value as a result of some expression. In these two examples, value is being assigned directly. In this example, value is being assigned as a result of some calculation. So this type of work is used a lot. Then in fourth example, we are seeing a calling of a predefined function sign. d is equal to sine of c. Sine is the known trigonometric function that we know about, and in this case d is actually the sine of value c. If you are using sine c, that means c is some angle in radians. This function sine is a predefined function which is already defined inside MATLAB, and it expects argument value in radian unit. If you have data in degrees, is in place of sine c, you should use sine d of c, just like this. If the argument is in degrees, then sine d of the argument is the correct function to be used. That will calculate the correct value. If for a degree data you use this function, it will wrongly calculate the value. If the data is in radian, use this. If the data is in degrees, use this. Next, you see that d is equal to 0.6503, which is rightly the value of sine of 15 radian. This is the value of sine of 15 radian, not 15 degree. Now the next example is of this tan c. You can see one difference, that in all the previous example we had some output variable in which the value was being assigned, but here no output variable has been shown. Only tan c is written on the command window directly. Nothing, tan c is not equal to anything. No output variable like d, c, a or b has been written in this line. So what happens, the moment you write tan c and hit enter, it gives the result ans is equal to minus 0.8560. Ans is actually the predefined default output variable. If in a line we do not write any output variable, MATLAB provides a default output variable in which the result of the last calculation is stored. In this case, since we did not define any output variable, so MATLAB provided its own default output variable in which the result of the last calculation tan c got stored, and it is displayed, echoed on the screen like this. Answer is equal to this. So answer or ans is predefined default output variable in case of MATLAB. Like all other calculation, here we have shown the division operation also. This much we have already discussed, that MATLAB is so called because it is matrix laboratory. It is a high level programming language. In MATLAB, everything is seen as a multi-dimensional array. The dimensions of an array can be 1 and 1. If a scalar is there and we have to store a scalar number, it is seen as a 1 into 1 matrix. Vector quantity is seen as a 1 into n or n into 1 matrix, either as a row matrix or column matrix. We will take a look at it in later slides. So this is why, because everything inside MATLAB is array or matrix, this is why it is called matrix laboratory. So now, because everything that we are doing in MATLAB is arrays, so let us see how do we create arrays. So simplest example is if we create a one-dimensional array. First example is A is equal to an array, one-dimensional array having 4 elements 19, 28, 37 and 46. To create this an array, we need square brackets. The data should be enclosed inside square brackets, and it should be delimited by space or by comma. Both these forms are equally correct. You can either separate them by space or you can separate them by comma. A is equal to 19 space 28 space 37 space 46 is same as A is equal to 19 comma 28 comma 37 comma 46. So you can, for delimiting purpose, you can either use comma or space equally well. Both these will generate a one-dimensional matrix which has, or a one-dimensional array which will have one row and multiple columns. In this case, the number of columns are 4. You can see it, if we look at it in the form of as if it is a matrix, we see that this is just one row, and one row has multiple columns. So the dimension of this is 1 into n, or 1 into 4 in this case. This is the simplest array, a one dimensional array. To create two dimensions, to bring about two dimensions in the array system, you have to specify multiple rows, and every row is specified, and every row has to be separated from the next row. So to separate adjacent rows individually, MATLAB has the facility of, as the feature of putting semicolon in between two rows. You see, B is being defined in a slightly different manner. A has just one row. B, first row of B is similar to A. Then after inserting three elements, you see that there is a semicolon appearing. Semicolon is, the purpose of semicolon over here is that it indicates the end of one row and beginning of another row. So the moment semicolon appears, control understands that one row has ended and another row will begin from the next number. So first row is this, semicolon, next row, semicolon, next row. So in this way we have 1, 2 and 3 rows. When the control echoes its output on the command line, you see that these rows are properly arranged. After getting properly arranged, they look like this. Row number 1, 19, 28, 37. Then after semicolon, second row comes over here. After semicolon, third row, 83, 92, 101. It has been rightly put on its desired location. So it takes the form of a 3 into 3 matrix. This is a two-dimensional matrix. That was one-dimensional matrix. This is two-dimensional. Size is a special predefined function inside MATLAB which gives us the idea what are the dimensions, or more precisely size of an array or matrix. It expects an array as its argument, and when you call this function like this, for example, when I write size A, that means it will return the value of the size of A or dimensions of A. In this case, we can see that A is actually one row and 4 columns. This is why it is producing the output 1, 4. First part is row number of rows, second part is number of columns. So size function is used to know the dimensions or size of an array or matrix. Similarly, when we call this function to know the size of B, like this, it tells you 1, 4, like this. Right. To know the size of B, it tells you that this is a 3 into 3 matrix. When we use the same function on B, because B has 3 rows and 3 columns, it gives the size. This is the size of B matrix, which is simply 3 into 3, because that is how we have defined it. So after knowing what is the arrangement of various types of matrices, one dimension, two dimension, for the sake of simplicity we are considering only one dimension and two dimension only. There can be three dimensional and multi-dimensional matrices also, but they are a very large data set and are rarely used. This is why we are not getting into it, because this is a very basic lecture. In this part we have defined a matrix B, which is a 3 into 3 matrix. Then we are performing an addition operation on the matrix. Addition, we are adding not a matrix to the matrix B, but a constant number 25. 25 is, we can consider it as a scalar value, but MATLAB sees it as a matrix also, but it is just a 1 into 1 matrix. And we are doing this B plus 25. That means 25 will be added to every element of this matrix. This is element wise addition. The moment you add a constant value to a matrix in MATLAB, it is added to the every element throughout, and it becomes an element wise addition. So every number inside this matrix B is increased by 25. You can see 19 has now become 44, 28 has become 53, 37 has become 62, and so on. Then square root function. Square root is again a predefined function which performs operation of calculating the square root of an array or matrix. So in this case we are passing b as an argument to this function, and it is calculating square root of all the elements of b. So every element of b has been passed to square root function, and it has calculated square root for every element. So this is again an element wise operation. So these were the arithmetic operations, but there are certain array operations also which are very important. For example, the most important array operations or matrix operations are calculation of transpose and calculation of inverse. Calculation of transpose means except the main diagonal, all other elements are swapped. For example, A21 is swapped with A12. Element of row number 1 and column number 2 should be swapped with element of row number 2 and column number 1. So about the diagonal, if everything is swapped, that is called transpose operation. So this is a very important operation that we do it a lot in matrix mathematics. So transpose has to be calculated. Very easy method to calculate transpose of matrix, however large it is. It can be a 3 into 3 matrix, or it can be a 100 into 100 matrix also, but just by putting a prime. When you write b prime, that means output will be transpose of b. B is this, output will be transpose of b. You can see from here that position 19, 55 and 101 remains as it is, but 28 has been replaced by 46 and 46 has been replaced by 28. So swapping has taken place, which is rightly called the transpose. Next most important operation of matrices is inverse. To calculate inverse, there is a predefined function again to calculate inverse of any given matrix. So if the inverse is, so if we pass matrix to the inverse function as an argument, it will generate its inverse. So how do we make sure that this inverse is correctly calculated? You can always multiply the number with its multiply the matrix with its inverse, and it should generate identity matrix, which is correctly being checked over here. B is being multiplied by inverse of B, and it is generating an identity matrix. Identity matrix has ones all over its diagonal and zeros all other locations. So diagonal is 1 1 1, but other elements are all 0. This is correctly an identity matrix. It has been obtained by multiplying B with inverse of B. That means this function is correctly calculating the inverse of B matrix. So because of the fact that we have trigonometric functions like sine, we have the capability of operating operations like transpose, calculating inverse, calculating other mathematical functions is very easy, because there are predefined functions already present in MATLAB. So you don't have to write a function from scratch for every operation that you need to do. So because of the fact that there are so many predefined functions, life becomes very easy when you program using MATLAB. Next, we should talk about another mathematical operation, product. Now product can be of two types. We can be doing matrix multiplication, or we can also be doing simple arithmetic multiplication. So the difference is, for doing matrix multiplication, you just have to put star between two matrices which are being multiplied. For example, in the first example, B star B, that means B star B or B asterisk B. So B star B will generate matrix multiplication, result of matrix multiplication between B and B. But to do scalar multiplication or element wise multiplication, the only difference is we put dot star in place of star. So the moment you put dot, it becomes element wise operation. Without dot, it remains matrix operation. So B dot star B is not a matrix multiplication, it is element wise multiplication. That means every element is being multiplied by itself and the square is being generated. This is the square of element, this is the square of 19, this is the square of 28 and so on, but this is not the square of 19. This is matrix multiplication, which involves multiplication of row. See, Matrix multiplication happens when row of one matrix is being multiplied by the column of another matrix. This is how matrix multiplication happens. So when this type of pattern is followed, that rows are being multiplied by corresponding columns and sum total is calculated, that is matrix multiplication. Matrix multiplication is happening in this case. This is how this matrix is being calculated, but it is not happening in this case. Why we have suppressed matrix multiplication? Because we don't need it, because there can be a situation in which we don't want to perform matrix multiplication. Only simple element wise square or multiplication is required. So for doing that, we smartly put a dot over here, and the moment command line sees dot star, it performs element wise multiplication. So this is not the result of matrix multiplication, it is the result of element wise multiplication. Similarly, you can calculate cube. In this case, b star cube is being calculated. So b star cube, b dot caret 3 is actually cube of b, which is being calculated. So in this case, you see that it is caret. Caret means power. Anything followed by any number followed by caret is actually that power which should be calculated. So b dot caret 3 means cube of every element is required. So it calculates cube of every element of B matrix. Next most important operation is concatenation. Concatenation means combining two matrices together. You can combine two matrices in two ways. You can either combine them horizontally or vertically. So if you want to combine them horizontally, this is the simplest method of doing the concatenation like this. So if you want to combine B with itself in a horizontal manner, so that it should extend horizontally, that means we are interested in increasing the number of columns. So it is written like this. This means B comma B, that means they will be combined in horizontal manner like this. To combine them vertically means that we want to generate more number of rows. To generate more number of rows, the simplest way of doing it is by writing it like this, semicolon between B and B. By writing semicolon, you will see that after B, another the second matrix will be shifted at the bottom of the first matrix. So it will be concatenated in vertical direction. This is horizontal concatenation, this is vertical concatenation. Next most important feature of MATLAB is the complex numbers. So in today's lecture, we'll just take a look at how complex numbers are recognized. You see, no other programming language of yesteryears, for example C, is not able to recognize complex numbers. C, for doing complex mathematics in C, you have to create different variable for imaginary part and a different variable for real part. But modern languages like Python, it is able to recognize complex numbers, and MATLAB is also able to recognize complex numbers. So complex numbers are displayed in this pattern in MATLAB. You see, we are calculating square root of -1, which should be equal to iota, and it is written like, it comes out like this. These many zeros are because of the fact we are using long format of numbers. By forcing that format to short form, we can if we again calculate it, it looks something like this: 0.000 plus 1.000 I or j, both are acceptable as the indicators of imaginary part. In place of I, you can also use j. As we have shown in this example, Cn is a complex number which is actually an array of, is a complex array of several complex numbers. Complex numbers of which the elements are 2 plus 7.5i, comma minus 3i, comma 12 plus 12j, comma minus j. So you see that we can use I as well as j to indicate complex numbers. So after hitting enter, it shows the result something like this. So in this way we because in scientific computation complex numbers are very useful. Quantities like electric field, etc., they are actually represented in complex numbers, and their phase and other things are calculated later on. So this is why complex algebra is integral part of scientific calculation. So software that we use should be capable of doing it. This is why complex numbers have been incorporated in MATLAB. So because of this reason, MATLAB is very popular in scientific calculations. This is all for this part of the lecture. In the next lecture, we will take a deeper look into the indexing and slicing and other features of MATLAB and other advantages. Thank you.